Did you know that China's high-speed rail, often described as completely indigenous, actually relies heavily on purchased technology? The so-called core technical patents were reportedly stolen. The key to China's high-speed rail success appears to be the strategy of, if you can't make it, buy it. If you're outmatched, steal it. A professor, believed to be from a Chinese university, recently exposed a major scandal involving high-speed rail. This project is considered the most important among China's four great new inventions.
Back then, high-speed rail technology was led by experts, and they all advocated for independent development. But independent development isn't always the right approach. Class, do you know how long it would have taken China to develop high-speed rail on its own and get it running like it is today? We ran the numbers. We took on a project for the Ministry of Railways to compare independent development versus comprehensive introduction, using the market to exchange for technology. Do you know what we found? If we had relied solely on independent development, based on the expertise and capabilities of our specialists, how long it would take to reach today's high-speed rail standards? 400 years. Class, do you agree? That's why the Ministry of Railways went with comprehensive introduction.
In his lecture, the professor allegedly told students, independent research and development is just a lie. It's meaningless. Our real independent technology is theft. China's comprehensive introduction strategy often involves buying products and demanding technology transfers for local production. These agreements usually include strict conditions, such as limiting the technology's use and prohibiting exports. However, China reportedly ignores these terms. Once the technology is obtained, agreements are torn up or the products are reverse engineered. This allows mass production and market dominance with low prices. The professor seemed to embrace this approach and openly taught it to his students. But this professor may have oversimplified things. In recent years, China's comprehensive introduction strategy has started to fail on a larger scale. The problem lies in the difficulty of replicating critical components and core technologies. When access is restricted, the counterfeit products often fail to meet performance standards. Huawei has already become a global laughingstock in telecommunications. Now it seems China's high-speed rail is facing similar issues. Reports describe the system as suffering from joint pain. To understand the problem, let's look at the bearings, often called the joints of mechanical equipment. In manufacturing, there's a saying, wherever there is rotation, there's the need for bearings. Bearings are essentially components that support moving parts, reduce friction, and ensure precision. They're used in everything from airplanes and cars to high-speed trains and precision tools. Despite being known as the world's factory, China can only produce an oversupply of low and mid-tier bearings. It has no significant role in the high-end bearing market. Bearings for high-precision machinery, such as those used in high-speed rail and medical equipment, are largely imported. According to Chinese customs data, the country imported bearings worth $2.7 billion in the first 3 quarters of this year. In 2023, exports exceeded $4 billion. A report from Ruide, United Mechanical Equipment in Beijing, noted that China can only produce basic bearings for trains traveling under 140 kilometers per hour. For trains exceeding 250 kilometers per hour, China still relies on imports. Statistics show that China imports around $1 billion worth of high-speed rail bearings each year, covering more than 90% of the global market. Deputy Secretary General Liu Qiaofeng of the China Bearing Industry Association said that most high-speed rail bearings in China are imported. For example, CRH1 and CRH5 trains use bearings from Sweden's SKF, CRH2 trains rely on Japan's NTN and NSK bearings, and CRH3 trains use Germany's FAG bearings. Liu explained that China mainly produces Grade 2 and Grade 3 rollers, which account for 80% of production. Grade 1 rollers make up 5%, while Grade 0 rollers are less than 5%. The inability to mass-produce Grade 0 and Grade 1 rollers has become a major bottleneck for high-end bearings. In February 2024, the China Bearing Industry Association reported that China has nearly 10,000 companies making bearings or related products. However, high-end products make up only 5% of their output. Over 80% are low and mid-tier products. In 2022, China imported 2.7 billion sets of bearings, worth $4.6 billion. Experts note that imported bearings have a reliability rate above 98% and last 8 to 30 times longer than expected. In contrast, domestic bearings have a 96% reliability rate and only last 3 to 5 times longer. This means that being usable and being high performance are very different. As a result, China's C919 aircraft, Y-20 transport planes, and high-speed trains all use imported bearings. High-speed rail bearings need to meet very precise standards, with tolerances controlled at the micron level. This ensures that trains don't experience severe vibrations or deviations. The bearings must also have a reliability rate of over 98% and a lifespan 8 to 30 times longer than expected to avoid breakdowns. These bearings also need to be highly resistant to wear, corrosion, temperature, and impact. This ensures they work in a variety of environments and climates. China's reliance on imports extends beyond high-speed rail. Wind power equipment bearings are also imported. Only 33% of wind turbine mainshaft bearings are made in China, and those are mostly for turbines of 3 megawatts or less. The localization rates for gearbox and generator bearings are even lower, just 0.6 and 0.2% respectively. An official at the Chinese Academy of Sciences, Wang Dongsheng, said the biggest issue is material quality. He said, "Without quality steel, you can't produce high-end bearings." China has led the world in steel production for 26 years, but it still can't produce top-tier steel. Ultra-high-quality steel remains an unfulfilled gap. One key measure of steel quality is the oxygen content, measured in parts per million. Steel with 8 parts per million of oxygen is considered high quality, while 5 parts per million is top tier and essential for high-end bearings. Currently, China imports nearly all the steel needed for high-end bearings. Bearing steel, known as the king of steel, has proven elusive for China. The country invited leading global companies like Timken of the US and SKF of Sweden to set up operations in Shandong. However, it still failed to acquire the advanced metallurgical techniques needed for high-end bearing steel. China reportedly learned part of the process for making bearing steel from global companies like Timken and SKF. The key involves adding rare earth elements to absorb oxygen in the steel. However, while China understands the principle, it hasn't figured out the exact composition or ratios needed. Without this critical data, they've been left experimenting on their own. These experiments haven't gone well. Adding rare earth elements often leads to inconsistent steel quality, and the process frequently causes blockages during production. Despite years of effort, China has not been able to overcome these issues. To this day, they still can't produce qualified bearing steel. China's high-speed rail expansion relied heavily on technology from Japan's Shinkansen and Germany's Siemens. But during this process, China reportedly broke agreements, reverse-engineered designs, and stole patents. After producing knockoffs, it competed directly with its former partners in global markets. These controversial methods have severely damaged the reputation of Chinese high-speed rail. The consequences of these actions have led companies like Timken and SKF, which originally built factories to supply China's high-speed rail, to stop sharing their core manufacturing technologies. They now refuse to transfer critical know-how, like the techniques for producing bearing steel. China's inability to make high-end bearings has hurt industries like high-speed rail and wind turbines. The problem isn't just with materials like bearing steel, it's also about equipment. China lacks the advanced tools, such as CNC machine tools, needed to manufacture high-end bearings. Industrial machine tools, often called the mother machines of manufacturing, are critical for high-end production. High-end CNC machine tools are among the most profitable and advanced equipment globally. But for years, China has struggled in this field. According to a 2022 report, China is the world's largest producer and consumer of machine tools, with its domestic market expected to exceed 570 billion yuan by 2024. Globally, companies from Japan, Germany, and the US dominate the high-end CNC machine tool market. A 2019 report revealed that the top 10 manufacturers of CNC machine tools are from these countries. Japan's Mazak alone had a market value of $5.3 billion in 2019. Meanwhile, Chinese machine tool exports in 2021 totaled $8.7 billion, while imports reached $8.2 billion. What stands out is the massive price difference. The average export price of Chinese machine tools was around $300, or about 2,000 yuan. In contrast, imported tools averaged $76,750, or over 510,000 yuan. This shows that China exports low-end tools with minimal profit margins, while high-performance CNC machines are entirely imported. General Manager Ding Wei-ming of Dalian Machine Tool explained that domestic machine tools lag behind international brands in 3 key areas: precision, stability, and efficiency. Even with similar components and equipment, Chinese tools simply don't perform as well. Experts have pointed out that the real gap between China's machine tool manufacturing industry and leading global players lies in the attitude towards precision management and lean manufacturing. For example, many are familiar with stories of German and Japanese manufacturers spending decades perfecting a single blade or nut. These stories reflect a deep culture of craftsmanship and advanced technical skills. In the machine tool industry, every component must be made with extreme precision. This is especially true in precision manufacturing, where every step is interconnected. Even a seemingly simple blade can significantly impact the accuracy and efficiency of subsequent processes. High-end CNC machines rely on precision spindles, which in turn depend on advanced bearing systems. Since China can't produce high-end bearings, it also can't manufacture advanced CNC machines. This creates a cycle where the lack of advanced tools makes producing high-end bearings even harder. Looking ahead, China's struggles with bearing steel are expected to worsen. Without this core material, China's high-end bearings will remain dependent on imports, which are likely to become even harder to secure. China's manufacturing industry has long relied on copying existing technologies. This has left it without the experience or innovation needed for independent breakthroughs, creating a cycle of dependency. One well-known example of this is the production of ballpoint pens. A 2016 state media report revealed that China, despite producing over 40 billion ballpoint pens annually, still had to import the tiny balls used in the pen tips. China has struggled to move from low-end to high-end manufacturing, largely due to weaknesses in material science. Critical industries like precision tools, gas turbines, and semiconductors all suffer from this issue. Despite significant investments in research, progress has been slow. Even producing pen tips became a national embarrassment when then-Premier Li Keqiang publicly criticized the failure. Professor Ren Tianbing at Tongji University identified two key challenges. First, material technology is hard to replicate. Unlike consumer goods, materials don't reveal their composition or manufacturing process just by observation. Second, developing new materials requires huge investments in time and money, but the resulting breakthroughs are easy to copy. This discourages companies from investing in research. Even if you examine a material, it's difficult to figure out its composition or production process. This is different from many other products like appliances, where disassembly reveals the components and makes learning and improving easier. The second problem is the high cost of development paired with how easily others can copy the results. Many companies hesitate to invest heavily in new material development because of this. High-tech materials and specialty chemicals require significant time and money to move from research to industrial production. Once breakthroughs are made, the trade secrets are hard to protect. Technologies can spread illegally and require minimal investment for others to replicate. He noted that the inability to produce high-end pen tips isn't just a technical issue, but also a market problem. This challenge exists in many industries in China. Technically, some products meet high standards, but market factors like price or branding make it hard to sell quality goods. Counterfeits and substandard products dominate, making it harder for legitimate companies to survive. A company may spend significant resources on innovation, only to have its products copied and undercut, which erodes profits and discourages further improvements in quality. Honorary Vice Chairman of the China Writing Instrument Association, Chen Sanyuan, explained that producing a tiny ballpoint pen tip requires more than 20 separate steps. Traditionally, these steps had to be handled individually. To meet export demands, China pen manufacturers have widely adopted integrated production equipment from Switzerland's Micron, which helps improve quality and efficiency. But these machines require higher quality materials, which China doesn't produce. Manufacturers have had to import stainless steel wire from Japan and ink from Germany or Japan. This has created an awkward situation where China leads in pen production but relies heavily on foreign materials and equipment. China's high-speed rail, once promoted as one of its 4 great modern inventions, is now facing complications. The joint pain caused by a lack of high-quality bearings highlights the deeper issues in China's manufacturing sector. These include a short-sighted focus on quick results, a lack of technical development during the research phase, neglect of intellectual property protection, and rampant bureaucratic corruption. Together, these issues have exposed the fragile foundation of China's supposed manufacturing boom. Even more concerning, many foreign employees working in China or visiting on business, as well as international tourists, specifically take rides on China's high-speed trains to experience what's advertised as the fastest rail system in the world. If they knew about the current joint pain plaguing China's high-speed rail, they might reconsider and take greater care to prioritize their travel safety.